So in Chapter 14, we studied the output and pricing decisions by competitive firms and what happens at the industry level in perfect competition. In Chapter 15, we looked at the exact opposite case when there's only one supplier in the industry, there's no competition, and the provider makes both the decision about output and price in the marketplace. In the next two chapters, we will look at the cases in between when there is some amount of competition or interaction among companies. In Chapter 16, we look at oligopolistic markets, which are the markets with a relatively small number of providers. And because there is a relatively small number of providers, you can think that the providers are not anonymous. Each company observes how many other providers there are in the market, and each company realizes the interdependence among the companies. Each company realizes that it can affect its competitors' profitability, and it realizes that the price and quantity decisions by competitors affect my own profitability. And we will say that generally there is a trade-off between the decision to compete with competitors and cooperate with them. So, to summarize the differences between different types of market that we could have, so far we've discussed the extreme cases of monopoly and perfect competition. We said that with monopoly we had a single firm. With perfect competition we had many very small firms in the industry, and we assumed that the product made in these industries is homogeneous. In oligopoly, we will continue assuming homogeneous product, but we will look at the case when there is a small, finite number of producers. In Chapter 17, we will look at monopolistic competition, the case when there is a larger number of firms, maybe same number of firms as in perfectly competitive industries, but the product produced by each firm is slightly differentiated. Oligopolistic markets are characterized by relatively few sellers offering very similar product. So here we're not focusing on product characteristics. Once again, companies are only choosing their output level or price, but they recognize the interdependency of their payoffs. We will say that the companies would be best off if they cooperated with each other fully, but we will say that the fully collusive solution is not sustainable because both companies have face trade-offs between cooperation and competition, and in the solution with perfect collusion, both companies would have an incentive to deviate from the collusive agreement and cheat on it and compete with each other a little bit more aggressively. So we will say that depending on the model of competition and interaction between the companies, the outcome will be somewhere between the fully collusive solution and perfectly competitive solution. As a small digression, when there is a small number of competitors in the market, we could model their interaction as a competition in prices or competition in quantities. So one idea how competition between two firms could work is that companies choose their price. If the companies were choosing the same price, they would split the market between themselves. Perhaps each of them would supply half of the market at that price. But both companies know that if they cut their price just a little bit, they could capture the entire market. Remember that the product is homogeneous under all of the assumptions that we placed on our model, such as perfect information by consumers. As soon as one company cuts its price a little bit, all consumers will flood to this producer, and this company will supply the entire market. And so we will say that in a model of competition, when the competition is in prices, both companies have the incentive to undercut each other just a little bit to go from supplying half of the market to supplying the entire market. The solution to that model of competition would be that the price would be competed all the way down to the level of marginal costs of production. So if we model companies as competing in prices, we would get the same solution as in perfect competition. And the intuition here is that, remember from chapter 15, where we discussed the output effect and the price effect faced by the monopolist. The monopolist was deciding how much to produce at what price, and each time he changed quantity or price, he faced both the output effect of supplying additional consumers and the price effect of charging lower prices to existing consumers. We can say that with competition in prices, or the Bertrand competition, the output effect dominates. As soon as the company charges slightly lower price than its competitor, it gets to supply the entire market. Its output increases significantly. On the other hand, the price reduction can be very small, so we can ignore the small reduction in price that this company charges. So because the output effect was so significant compared to price effect, we get the result that prices would be competed down to the marginal costs. On the other hand, we could model the interaction among companies as competition in quantities, so-called Cournot competition. And in that situation, companies choose how much to produce. And when both companies choose their output level, consumers look at the aggregate output produced and determine what the market price of this product will be. In this case, we will get the same result as in monopolistic markets, that there's both an output effect and a price effect. When the company decides to produce one more unit of output, on one hand, it faces the output effect because the company can collect price one more time from the additional unit of output produced. On the other hand, there is a clear price effect because with an additional unit of output produced, price in the marketplace will fall clearly, and companies realize and companies have to balance these output and price effects of their quantity choices. We will illustrate this on the next few slides. Okay, so let's look at an industry with a demand curve, with a linear demand curve. Suppose that marginal costs of producing this commodity, the marginal cost is 0, and looking at this graph, I want you to already think about what would be the solution in different forms of the industry. If we had a perfectly competitive market, then prices would be competed down to the level of marginal costs. So this would be the market solution. If we had a monopoly operating in this industry, then the monopolist would choose quantity where marginal revenue is equal to marginal cost. We would say that the solution has this output level and this price level in the market. And now the question is, what happens in oligopolistic markets? And as I said, that depends on the interaction between companies. As I said, that if the companies compete in prices, we might believe that prices would be competed down maybe almost to the level of marginal costs. And in that case, the oligopolistic output could be close to the perfectly competitive output. Or if we think that companies compete in output levels, we will say that the market solution really could be anywhere between the monopoly outcome and the perfectly competitive outcome. To solve this numerically, we should look at the profits that companies can earn from any quantity choice. Okay? So in this table, I computed the profits that each company would make if it produced a particular amount of output and if its competitor produced a different level of output. So on this graph, each row corresponds to, each row gives us the profits that company 1 and company 2 would earn if company 1 would produce 30, 35, 40, and so on units of output. Each column gives us the profits when company 2 produces 30, 35, 40, and so on units of output. You can think that 30 and 30 units of output corresponds to the monopoly output. 60 units is the aggregate amount of output. And if the companies could collude and agree on this level of aggregate output, each of them would earn $1,800 of profit. If companies produced large amount of output, such as 60 and 60, which would be the perfectly competitive output level, each company would earn 0 profits because price would fall to 0, to the level of marginal costs. And looking at these payoffs, we can see that the profits clearly change depending on how much each company produces. And the way to understand this table is each company is looking at this schedule of profits, and each company is choosing how much to produce based on how much its competitor is producing. So suppose that company 2 is producing 30 units of output. How much would company 1 choose to produce? Company 1 would choose at its different profits, and it would realize that producing 45 units gives company 1 the greatest profit. So if company 2 produced 30 units of output, company 1 would choose to produce 45 units of output. So now we have decided that company 2 might choose to produce 45 units of output. What will company 2 want to do? Will it really want to produce 30 units of output, or will it want to do something else? So looking at this row here, we would compare the profits that company 2 can make, and we would find that either 35 or 40 units of output give it the greatest profit. So suppose that company 2 chose to produce 40 units of output. The question is, would company 1 still want to produce 45 units of output? Again, company 1 would compare the profit that it can make, and now it would choose, now company 1 would decide that actually producing 40 units of output gives it greater profit than producing 45 units of output. And if the company 1 chose to produce 40 units of output, let's check whether company 2 would still want to produce 40 units of output. And yes, indeed, we can find that when company 1 is producing 40 units of output, company 2 would produce also 40 units of output. So now we have found that if this is a possible market outcome, each company would want to stay at this schedule of output levels. Neither company would want to move. Okay? So we can say that this is one possible market equilibrium. If company 2 believes that company 1 will produce 40 units of output, company 2 will also find it profit maximizing to produce 40 units of output, and vice versa. We could also find that there are two other possible equilibria. So in general, without knowing about bargaining power between the two companies, it's unclear whether this would be market outcome or this market outcome. We can say that depending on companies' beliefs and bargaining power, we could end up either here, here, or here. So looking back at the market demand curve, now we have determined that in a duopoly where companies compete in quantities, 80 units would be the aggregate output level. So we would say that the market solution in this oligopolistic market would be to produce 80 units of output total at this particular price level. Okay? And okay. One other way to think about this problem, so if we want to illustrate this problem graphically, let's look at the market demand curve and think about each company's problem. So company 2 is thinking how much to produce. Company 2 observes how much company 1 is producing. So suppose company 1 is producing this output level. And given this output level by company 1, company 2 is thinking that it has a residual demand that looks like this. After this many consumers are served by company 1, company 2 can choose how much to charge and how much to supply to the other consumers in the market. Right? So after subtracting these consumers from the aggregate market demand, company 2 is choosing its quantity and price for the remaining consumers. We can say that company 2 is acting as a monopoly on this residual in this residual market. So we could find company 2's marginal revenue curve on this residual demand, and to maximize profits, we would realize that company 2 wants to produce where marginal revenue is equal to marginal cost of production. And we would say that given company 1's output level, company 2's profit maximizing response would be to produce this output level here. So, and once we solve for company 2's optimal response, we would go back and evaluate whether company's 1 output level was indeed profit maximizing. Given that company 2 wants to produce this output level, how much would company 1 want to produce? We would perform the same analysis where company 2 supplies particular portion of the total market. Company 1 has a residual market with a residual marginal revenue curve, and company 1 is choosing its profit maximizing output level. And we would go through this analysis, studying each company's choice of quantity in turn until company 2's optimal response, until we get the output levels of the two companies as optimal responses to each other's quantity choices. So in the solution, we would find that company 1's output is a best response to company 2's output, and company 2's output is a best response to company 1's output. That's really what this table summarizes numerically. Okay. Now let's compare the possible solutions in different market structures. So far we said that in a duopoly with competition in quantities, either of these three outcomes is possible, depending on firms' beliefs and firms' bargaining power. We said that in monopoly, this would be market outcome, and in perfect competition, this would be the market outcome. Notice that the monopoly outcome gives greater profits, gives greater aggregate profits than the oligopoly outcome. So here you should think that if the oligopolists talked to each other, if they could limit their output levels to 30 units of output, profits of each company would increase from 1,600 to 1,800. But the question is this solution possible? Notice that if company 2 produced 30 units of output, as we discussed already, company 1 would not find it profit maximizing to stay with this output level. It would choose 45 units of output rather than 30. So we can summarize that even if the two companies collude and agree to produce a small output level, each company will have an incentive to cheat on the collusive agreement and produce more. Okay? This is the kind of interaction that game theory studies. Game theory is a subfield of microeconomics that looks at the decisions of companies and people in strategic situations. Whenever there are trade-offs to be made between cooperating and competing with each other, game theory can be used to study the optimal decision-making using a very simple model. We would say that the solution to a game theoretic situation is a Nash equilibrium, and the Nash equilibrium is defined as the outcome when each decision maker chooses the best strategy for himself given the best strategies chosen by its competitors. The simplest kind of game theoretic situation is a so-called prisoner's dilemma. The example goes like this. The police catches two prisoners and holds them in two different cells in the prison, and each prisoner has an option to remain silent or to confess all the crimes. And because police has limited information on the two prisoners' crimes, if both prisoners remain silent, the police cannot hold them in the prison for too long. Suppose that the police will be able to hold them in prison only for 1 year, because there is limited evidence on the crimes committed by the prisoners. On the other hand, if both prisoners confess, the police can hold both of them in prison longer because it has more evidence on the crimes. And to induce prisoners to confess, the police can offer prisoners some incentive, such as if only one prisoner confesses, so if we go from remaining silent, if only Clyde confesses and Bonnie remains silent, the police could promise to Clyde that the police will release Clyde, that Clyde will not have to serve any sentence in the prison. So notice that in this simple situation we have 4 possible outcomes. We know the payoffs to each player, to each prisoner. And looking at these numbers, it looks like remaining silent for both prisoners would be the best outcome. In all other outcomes, either both prisoners have to serve high sentences, or at least one prisoner has to serve high sentence in prison. So, but what happens in this situation? Notice that, let's think about this, the strategy of Clyde's. Now, what Clyde does clearly depends on what Bonnie has chosen. And the payoffs to Clyde also depend on what Bonnie has chosen. Suppose that Bonnie remains silent. What would Clyde decide to do? Would he decide to remain silent or to confess? We can say that, we can see that by remaining silent, Clyde would go to prison for 1 year. By confessing, he would get 0 years of prison. So it's optimizing for him to confess. Now, what would Clyde do if Bonnie confesses? Again, looking at the payoff from remaining silent to the payoff of confessing, we see that it's optimal for Clyde to confess. So we can summarize that it doesn't matter if Bonnie confesses or remains silent. It's always optimal for Clyde to confess. We would say that the dominant strategy for Clyde is to confess. And because the table is symmetric, we would get the same conclusion for Bonnie. Regardless whether Clyde confesses or remains silent, it's optimizing for Bonnie to confess. 8 years is less than 20 years, 0 years is less than 1 year. So we just figured out that the dominant strategy for both players is to confess. So surprisingly, even though this solution is clearly better for both prisoners than this solution, through this, this interaction of trade-offs to cooperate and to compete with each other, both prisoners decide to compete and confess. The textbook goes through several examples when this framework of a prisoner's dilemma can be used. We can see that oligopolistic competition can be studied using the framework of a prisoner's dilemma. Nuclear threats can be studied using this framework. Extraction of natural resources and decision to drill for oil can be used, can be studied in the same framework. And so the surprising result we get is that the efficient or the welfare maximizing outcome is not the equilibrium outcome in those situations. Now, one criticism of these games could be that they always assume that the game is played one time only. And we might ask, what happens if the game is repeated over several time periods. Suppose we might hope that if the game is repeated sufficiently many times, 3 times or 10 times or 100 times, maybe both prisoners would realize that sustaining the efficient outcome is beneficial to both of them, and through repeated interaction we could get the efficient outcome rather than the competitive outcome. Again, kind of surprisingly, we can derive that if the players interact in a finite number of time periods, we will get the same result as in a one-time game. Suppose that Bonnie and Clyde interact in 3 time periods. Let's think of their decision-making in the last time period. In the third time period, when there is no future interaction among them, Bonnie and Clyde will think whether to confess, whether to remain silent, and because they're not facing any further interaction in the future, they will make the same decision as in a one-shot game. So in the last period of a repeated game, they will choose the same strategy as in a one-time game. Now in the second time period, so one time period before that, they realize that in the next time period they will not cooperate with each other. And because there is no beneficial future cooperation between the players, even in the second time period, they will decide not to cooperate with each other. Again, they will decide that their dominant strategy is to confess and not cooperate with each other. So, because there was no possible cooperation after the third time period, there was no possibility of cooperating in the third time period. Because of there was no likelihood of cooperation in the third time period, there was no cooperation in the second time period. Finally, because there is no likelihood of cooperation in the second or third time period, even in the first time period, the players will choose not to cooperate with each other. So surprisingly, even if we have many time periods in which the players cooperate, even 100 time periods, if we solve the game from the last period to the first time period, we would find that there is no cooperation. Only if there is a positive chance of cooperating in the future can we get cooperative outcome between the players.